Good morning, everyone. Selamat pagi, especially to our guests from Indonesia who join us today, together with our speaker from Universitas Gadjah. And I just welcome you all. This is our expert seminar series number 6 for 2021 in Seba. And we're delighted to have another international speaker for this seminar. And today we have with us Dr. Endang Sulistyaningsih from Universitas Gadjah, Jakarta in Indonesia. And Dr. Endang, just to give you a little bit of background about her, she obtained her doctoral degree from the United Graduate School of Agricultural Sciences of Kagoshima University in Japan. And currently she heads the doctorate graduate program in agricultural sciences in the Faculty of Agriculture at Universitas Gadjah in Jogja. Her expertise is in plant science, and her main research focus is on strain selection and improvement to develop seed bulbs for shallots and for the improvement of garlic adapted in lowland areas. And for those not so familiar, I think shallots, what will we call them in bahasa? Shallot.
Bawang merah.
Bunga merah. Okay.
Bawang merah.
Bawang merah. Okay, so the bawang merah shallots, and of course we need a different kind of seeds for growing them. So that is the area that she will be sharing with us today. So I now invite her to give her presentation on true seed of shallot for tropical shallot improvement. Welcome, Dr. Endang.
Okay, thank you, Dr. Jennifer, and also thank you to Dr. Nurhafiza. This already handled the preparation of my talk since sometime, maybe from some months ago. Good morning, everybody. I'm happy to be with you in this morning. So I will give a presentation in the title of True Seed of Shallot, TSS, for tropical shallot improvement. Tropical shallot plants genetically belongs to Allium cepa L aggregatum group with number of chromosome 16, and Shallot has sister. We call her sister. Sometimes say, why not brother? Has sister called onion with scientific name Allium cepa L onion group, and have same chromosome number 16. So you can see only a different group when we compare shallot to onion, but the name of species are same. Look at the figure of chromosome. We can see in row 1, this is a karyotype of shallot chromosome, and the second is karyotype of onion. The third is the hybrid karyotype plants between shallot and onion. In this karyotype, we can see the karyotype was similar, and in specific chromosome number 6, you can see in number 6, I make a circle here, which have a smallest chromosome, and sometimes we can see the microsatellite here in the row 1. We can see microsatellite, but difficult to see in other. We can see here small, very small. So this is a proof that shallot and onion have same characters in almost all morphologic characters. But maybe we can see in the data some characters are different. Shallot-tropical is a plant species adapted in tropical environments, while onion is adapted in subtropical condition. So Shallot produce aggregate bulbs. You can see from the picture here, many bulbs in a cluster, and difficult to produce flower and seed. However, onion produce single bulb like this from the picture you can see, and difficult to aggregate the bulbs, but it could produce flower and seed. So I gave explanation when both plants were planted in their environment. Then you can see from this slide, allium cepa flowering, both type of plants, onion and shallot. You can see from here, this is an onion type. The bulb is big, but not so many bulbs in cluster. But the right side is a shallot plant which produce many small bulbs, and the middle is a hybrid between onion and shallot. So the character also combine characters from onion and shallot. The habitus is high, similar to onion, but the bulbs can make aggregation. When we look at the florets, we can see also similar morphology of floret, but we can find one different character on the color of we say male organ. On this male organ, the onion show yellowish color, but the shallot show greenish color, and the hybrid show the greenish color similar to shallot. This is the just small different character, but make special character for both plants. So in this case, for flowering of the allium cepa, pollination factor is important, because in pollination we can adjust the low temperature which induce the flowering states. When we plant shallot in tropical area and become adapted in tropical area, this tropical shallot is not easy to develop flowers, except in a special condition. And I will explain that condition is when we plant shallot in highland, or now in some area in lowland also is possible to find some shallot plants develop flowers. In tropical shallot, we can see the specific characters such as bulb aggregation, and the bulbs show red purple color and small size in about 3 to 5 centimeter in diameter. And this character give the profit for us as agronome, especially also for farmers. We can plant shallot in a short time to finish the vegetatively stage. It means after the plant produce bulbs, like here from the picture. So this situation with the short time of vegetative stage, the shallot also give high productivity in about 10 to 15 tons per hectare from 1 to ton per hectare seed bulbs when we use as a material planting. You can see on the left picture, this is the situation plantation, shallot plantation in many areas in Indonesia. We plant like this. We make a bed and then we arrange 5 to 6 rows in each bed, and then we plant bulb, especially in vegetatively propagation. We plant the bulb in row spacing 15 centimeter to 20 centimeter. Now we find some problems in shallot when we use seed bulb as a vegetative material planting. Some of the problems are decreased seed bulb's quality caused by pathogen such as virus, fungi, and bacteria from soil and seed bulbs borne. So this is maybe this is a common problem in tropical area, because in tropical area the rainy season is take a long time, more than 1 month. In Indonesia, we get the rainy season from October to February, so almost 5 to 5 months. This condition make the environment high in humidity, and that situation is a good condition to develop the virus, fungi, and bacteria. Second problem is high weight of seed bulbs for material planting, because for 1 hectare we need 1 to 2 tons per hectare. So this seed bulb should buy for the farmers, and the cost is high. And the other side, when the farmers harvest seed bulb, and they should store the seed bulbs in their home, or they make a special storage, we call storage house. And then because some farmers cannot make their own seed bulbs, so they have to buy from other grower or farmer. So this make high cost in transportation. So I will explain one side of problem in shallot production, especially in virus. So virus in shallot, two kind of disease which caused by virus. There are onion yellow dwarf virus, we call OYDV, and shallot yellow stripe virus, we call SYSV from virus group, and shallot latent virus, we call SLV from virus group. And from Gunani et al. To 2011, we find a report that in 13 shallot cultivars from Indonesia, collected from farmers and seed bulb producer in West Java and Central Java, the population of all the 13 shallot cultivar were infected by OYDV and SYLV in about 40 to 100%. So it's a big problem, I think, if we we don't care about the virus infection. The symptom is not so, how to say, I call not so make damage in morphology phenomenon, but the yield potential will decrease. That report make information the production will reduce up to 63% caused by virus. So I give some picture from our research. This is from my master student, Pangestuti, in 2013. We find this is the symptom of shallot plants which infected by virus. Maybe not so clear from the slideshow, but we can see the stripe line yellow color in the leaves like this. So this character will appear in plants in age of 14 to 21 days after planting. Then we analyze this symptom with transmission electron microscopy, and we can get the result in virus infections, something like this, the particle of virus. When we use the microscope, we analyze this based on the reported by Solomon 2002, reported about the virus infection in allium. And then we try to do research in virus elimination through the electrotherapy and in vitro culture, and this part of the thesis research by my master student, Ratna Pangestuti. Let's see next slide. We see the salad seed bulb storage that I explained in previous slides. You can see this is the bulb storage in the home at the farmer. They put on the, how to say, we say part of roof, part of roof, but not on the, how to say, above of roof, but below of roof, like this. And the other one, they make a special storage house and make a rack like this. So this is how to say, they have to handle the bulb in a special space, and also they have to pay some costs here. So this slide, we can see how to find a solution in a seed bulb problem. So one alternative method, and now become an alternative material planting in shallot plantation, we use true seed shallot. We use the seed from shallot, and the question is why? In last decades, at least in last decades, we find in some tropical shallot are able to produce flower and seed in highland, and also in some lowland area, we also find many shallot plants can produce flower and also seed. Even still find some problem in the seed viability. Why in tropical area the shallot can produce flower? Because we 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 check the microclimate in the tropical shallot. Some months, in Yogyakarta, from July to August, we find temperature amplitude. It means difference temperature between day to night is wide. For example, in the day, the air temperature 32 centigrade, but at night become 27 centigrade. So this wide different temperature between day and night is enough to induce the flowering state in shallot. So before I explain, shallot can produce flower because of fertilization condition. Because in subtropical area, the plant can get the low temperature in winter. So in true seed of shallot, we find the condition of the flowering states of shallot. Shallot is in heterozygous states. It means the flower will will produce male and female flower organs, but mature in different time. That's make the states of shallot flower should, and when we make a crossing of the shallot, that's become open pollination because the different time of female and male and female organ mature. So this condition, I think some in initial research in TSS, I get the opinion it maybe it become difficulty in using of the seed shallot because the seed is not a homogeneous character. But with the status of heterozygous states in the shallot make us opportunity. The first thing is we still can get a genetic variation in the shallot seedling when we plant all the seed, and this is give a good chance in shallot breeding. I mean, we can improve some good character in shallot through this situation. And the second one, because we can make a selection from the TSS. Then in the second step, we can do the fixation of the excellent character of the variant we found in the plant from TSS with the homozygous technology, and we can get homozygous line of the shallot. So this is initial research in our team. We use seed production in highland in West Java. We plant in the plastic bag like this to make easy transfer this plant to the isolation place. We use a plastic house like this. So this is in the vegetative states. We open the area and then we transfer the plastic polybag into the plastic house to make a isolation of the flowering. So we can cover the flower to protect from open pollination from other how to say, variant. We want to make seed from the same variant, something like that. So from flower, this is a salad flower. After the pollination, we can obtain the seeds like this, very small, maybe only 1 millimeter in diameter. So this is a picture of salad flowering in lowland area, especially in my hometown in Yogyakarta. When we plant in July, we can get the flower in September. So need 3 months. Yeah. As commonly, we harvest the bulbs after 2 months. I mean, if we want to harvest the bulb, when we plant the shallot in July, we can harvest in August. Unfortunately, some farmer find the plants produce flower like this when they late to harvest the bulb. So they will find many flower like this. This is another problem at the time, because the quality of bulb become decrease. The sizes become smaller than before. So many farmer cut the flower, like cut all the flower. They don't know that they can get the seed. Then when we get the seed from lowland area, seed of shallot in lowland area, we try to test the seed using tetrazolium test. This is the embryo of the seed, and we find that many seed we get in the lowland area, the viability of the seed is low. We can see from the result the percent viability of the shallot seed range from 2% to 67%. So the reason is because the viability of the embryo is low. Next slide, we can see the step of how to use the TSS as a breeding material to improve shallot production. So first we germinate the seed in the special tray, something like this. With the I use total population 500 plants, and then transfer to the plastic bag like this. We observe the growth. Then we harvest the bulbs like this. This we call generation G0. You can see the character of bulb, almost all single bulb, but some variants show we call, how to say, the bulb is divided into 2 or 3, and this already show the character of aggregation. This from this population we make selection to the aggregation character of some population, because we think the plants with the aggregation character will support of the high productivity. I think many other character is also good for shallot, but you can make a ring, or you can make how to say a list which character is most important to select in the population. So after we harvest the bulb, we plant again, but the second is in the field, because we plant the bulb, not the seed anymore. Then in 2 months we harvest the pup. We call the pup is generation G1. Then we continue again, plant the pup again up to G4, G5. It means we plant the pup again in 5 times. I make a note for shallot pup. After we harvest, we cannot directly plant the pup because the pup need dormation states in about 2 months. So after we harvest the pup, we should make storage the bulbs in 2 months. After that, we plant again. So you can calculate the time is not not a short time, but we need little bit time to find the generation G5. So each generation we make evaluation for the aggregation character for the population. So for this one, in the I show the data of productivity from G3 to G5. You can see we make a group of the population, 4 group. Then we make a name as UGM1 to UGM4. So from UGM1 to UGM4, you can see in generation G3 to generation G4 in UGM1, the productivity still increase. But in UGM2, from G3 to G4, the productivity decrease. UGM3, in G4, increase the productivity, but G5 decrease. In UGM4, the productivity increase in G4, but decrease in G5. So from this result, we can see that G4 is the best high productivity. So this is the best stage for using the bulb in the field. I mean, we have to use the G3 when we will make the bulb in G3 as a plant material for vegetative material bulb. Because maybe many steps in using of TSS. First time in Indonesia, we think it's better the farmer use seed directly to the field, but many problem to germinate the TSS. Not the germination rate sometimes decrease after we keep the seed, for example, in 1 month. So the germination rate decrease in 60-100. So this is the problem for farmer. So the farmer said, maybe it's better we use the mini bulb. Mini bulb, it means some farmer plants the seed and the harvest G0, plant again become G1. So they sell the G1 to the other farmer, something like that. So from this result, we see the G3 is better material plant to G3 is better material to get the best result in G4. So this is the bulb character for UGM1 to UGM4. You can see the aggregation is similar, but so different character in the color also. So from this one also we can make another selection as a color, for example, like this. So the second step after we get the good variant in the TSS material, we can induce the homozygous line for Shallot using haploid. Wait a minute. Using do this using haploid induction and with material flower or florets in tissue culture. So I start this research in 2002 and then continue. I report in plant cell tissue organ culture in 2006, and I found the result haploid shielding is 1.3%. So we want to increase the result of haploid shielding, and we want to do the technology of double haploid in 2002. So I will see in this slide, when we do the double haploid technology, we can reduce the time to find the homozygous line. In this step, maybe we need only 2 to 3 years, yeah, compared to the conventional breeding. Because in conventional breeding, we do self-pollination and then make a selection in each stage of generation. Sometimes people need F6 and some people need up to F8. So need 8 to 10 years to get the homozygous line with 90% of homogeneous character. So the method still use my method in method 3, but we want to compare to other method reported by Alan et al. 2003 and Martinez et al. 2000 and 2003. But we make a minor modification in pre-treatment of flower bud. We we keep the flower stalk in the Yoshida medium, and then also we add jelly to ppm in the agar medium when we plant the flower. The composition of media and the step is same as reported by the researcher. So the step like this, the flower culture, we harvest the floret. It's not all. We harvest 3 days before anthesis. Anthesis is open. So we harvest the floret this size, maybe this one. I use the cursor. Then we plant the florets in the induction medium with the minor modification. So after 3 weeks, at least 3 weeks, we can in 2 days, not 2 days, 2 weeks, we can see the phenomena like this. But in 3 weeks, we can see the seedling emerge from the ovule inside the florets. And then when we wait 1 to 2 weeks, the leaves will develop. After this, we will transfer this seedling to the regeneration media. This is a haploid or double haploid plant. If we have a good chance, we can hope to get the double haploid, because double haploid plant is a material plant with a high fertility in the flower. But if we find only haploid, so we have to make a double chromosome to be the double haploid. So take time again. So the result is in this slide. So with the method 3, reported by Sulistyaningsih 2006 with minor modification, we can find that this method is still, I think, is the best method, because all the cultivar show same response or similar response in haploid seeding production. Maybe this is only one in Tajuk variety, no find the embryo, but in superperiod we can find the highest result, 6.98%, so higher than the result I reported in 2006. The how to say, the opportunity of the method 3 is simple step. I will back to the slide like this. Simple step, because only one step in induction medium and then transfer to regeneration medium. But in other method, they do two up to, this is two step, and then the third is regeneration medium. So I think this all my presentation. Thank you for your attention. If you have question, you can give the question for me. Thank you very much.
Thank you, Dr. Endang. So it's very interesting. This is, I think, a vegetable we all use every day, and maybe not realizing how difficult it is to propagate. And we just go and buy it in the market. So I'll start off the questions. Please, if other people have questions, you can raise your hand, or if you don't want to speak, we can also put the questions into the messages. Okay, so you told us a little bit about the problem with seed is that it's not viable for very long if it's stored. So that was one of the issues. For the true seed shallot, the bulb, how long can it be kept dormant before you have to plant it again?
From the seed or the bulb?
From the bulb.
From the bulb, 2 months, at least 2 months. We have to store it.
Yeah.
We have to store it.
How much longer can you keep it? Can you keep it for like 1 year?
Oh, yeah. How to say? If we can manage the storage with low humidity, for example, in 60%, only 60%. So you can keep in 5 months.
5 months, okay.
Yeah.
So
With the air temperature, I think air temperature is okay up to 32 centigrade is okay, and the lowest is, for example, 25 centigrade is okay. But the thing is the humidity. You have to decrease the humidity up to 60 to 65%. Higher than this, it's easy to sprout.
right. So it will start germinating too early.
Yeah. So
how do the farmers do this low humidity? Do they have any technology for that?
I gave the picture. The farmer put the bulbs on the roof, before the roof. So sometimes they make a smoke.
Okay. Will it get too hot up there?
In that case, it's okay because open area. So the how to say, the wind will make circulation of the humidity. But sometimes Indonesia, especially in wet season, it's so high.
Still going to be hot.
Yeah, 80%, sometimes 90% humidity. So in that case, the farmer make a smoke from how to say, they burn the charcoal or some organic matter.
Yeah.
Make a smoke, so we'll remove the humidity and the bulb is okay.
Have people tried using any like fan or wind blowing system?
In the isolation storage, like a storage house.
Yes.
They make exhausted fan.
Right.
to remove the humidity out, go out from the room. And then they adjust the temperature to maybe they can use the air condition, AC,
Yes.
aircon.
Yeah.
Adjust in 27
Right.
centigrade.
Yeah, because
So
I think we cannot. It's too hot here. I think in Malaysia to
I
put.
think so.
Yeah, so we always import. Okay, I think Dr. Fikri, you have a question. I pass the mic to you.
Yes. Good morning, Dr. Endang. Thank you very much. My name is Fikri from Seva. So my question is, I'm interested with the results that you showed on the UGM variants. So you showed that you have 4 variants that showed different yield quality, right? So for my question is, the difference that you saw in the yield from G3 to G4, is that due to the increase of the weight of the bulb per bulb, or is it due to the increase of aggregation of the bulb?
I'm sorry, I didn't catch the
Okay. So you showed that per hectare
meaning.
the meaning. So you showed that from G3 to G4, some variants showed increased yield, correct? So I was wondering whether the increase in yield is due to the variant having increased aggregation, or is it due to the increased weight or increased mass of the bulb itself?
Yeah. We still observe. I mean, I didn't report more for that variant because also time. So actually, from G5, we plan again the bulb to produce seed. The second seed, second step seed. Then we plan again the seed in that variant. We plan again and observe the character, and we can see that for example, in UGM 3, this variant saw the stable character in both in aggregation and the width. How to say the width? The width of bulb. But for the other variant, still not. I mean, these characters controlled by the gene. The gene, because actually in my research, the purpose is like this: if we plant the seed, is it possible the population or the plants from the seed directly produce aggregate? Because commonly when we plant seed, only one part.
I see.
The farmer don't like. Don't like. Why only one part? Even the size is big. The size of the bulb, because single bulb is big, but they don't like.
Yeah,
because don't like because the price is also not so high.
I see. Because that's my follow-up question. I just want to know what is the common or the attributes the customer would prefer. Is like, do they prefer a bunch of smaller but many bulbs onions, or do they prefer like a single bulb? Which characteristic is better? Because in the end, if you have the same weight, you have the same amount of onion, but then it's one is a bunch of small bulbs and this one is bigger, a single bulb.
They like they like the aggregation.
I see. So
not the single bulb. Aggregate, but medium size. Aggregate, but in medium size, because they still how to say, in the memory, aggregate medium size, it means the productivity high.
I see. Not
So
necessarily, yeah,
yeah,
based on
so
numbers, but then not based on
yeah,
weight.
both.
Mm,
Yeah, so I checked the result also linear.
mm,
Linear.
I see. All right. Maybe maybe I just let someone else to ask question. But I do have another one. So,
Okay, we may come back to you.
So I think is important with this material. I want to find the marker. What the kind of marker which induce the aggregation in the shallot, because if find this marker and find the gene, easy to control when we plant the seed. All seeds produce aggregates. At least, for example, for one seed will produce 5 bulbs, for example. Oh, it's nice, and the farmer will happy with this material.
Just before I go back to Dr. Fikri, I'm asking if there are any other questions. I'll also remind everybody, if you go to the messages, you will see there's a link to click on a feedback form. Please, can everybody give your feedback? And then we will collect that for our data analysis of the seminar series. So just open the dialog box and you can see a form. It's a very easy form to fill. It doesn't take you like 2 minutes. So please fill in the form. Are there questions from others? Or if not, we will go back to Dr. Fikri again. I don't see any hands. Anybody else? Shout out if you have a question. Or I think if you have any ideas on the markers as well. I think this one is definitely going to be related to meristem and the division into forming multiple bulbs. But I think it will be a very interesting character, because I think last time another researcher from your university was telling us that in the bigger onion, they don't want this like double bulb, right? Yeah.
Opposite.
It can be a trait that they select against in some kinds of onion, but it's obviously the other way around in shallot. So that is actually very interesting. And I'm not sure if anyone has found any markers for that yet. Okay, Dr. Fikri, the floor is yours again.
all right, just the follow-up question. I just wonder whether there is a difference between the onions, the shallots that was planted using seed bulb, difference in terms of the time for it to reach maturity, or the farmer can start to harvest. So you mentioned earlier it takes 2 months to from planting to harvest. So is there any difference between the ones being planted using seed bulb compared to the ones using TSS?
Yeah, of course. Different character, because when we plant with the seeds, first we germinate in the nursery and take 1 month, yeah, at least 1 month. After that, we transplant to the field, and from this transplantation, we need at least 3 months, at least. But this is another problem. I do another research from this step. Another problem is farmer didn't recognize the how to say, the phenomena of the senescent states of the plants from the seed, because in after 3 months the leaf is still green, and the seed, the how to say, the seed, I mean the part of shoot above the bulbs is still strong.
I see.
Commonly in the plants with seed bulb, after 2 months, the part is become weak and then fall down. But not in the seed.
From the seed.
Yeah, 3 months is still green, no senescent. So farmer are confused. Is it okay if we harvest in 3 months, or we have to make longer like that?
I see.
That is another problem, because we think if the farmer harvest even after 3 months, the leaf is still green. It means the translocation of photosynthesis is not finished. So we cannot find the maximum bulb weight like
Okay.
that.
So
So
do you think like trait like faster maturity time is it would be preferable for shallots as well? So maybe you can select for shallots
yeah,
that can mature.
that's I thought we can make how to say, we can make rank of the character. First,
I
I
see.
want to select the aggregation.
Aggregation.
Second is I want to select the clear sunshine like that, or short time of vegetative growth, not more than 2 months, something like that.
Yeah,
So that is another step of the selection with the
I see.
TSS to make a good variant, excellent variants.
All right, thank you very much.
Thank you.
Thank you. Are there any more questions? I think we will also have Dr. Endang's contact information. So I think this actually looks like a very interesting area. If there's any opportunities for us maybe to write grant proposals together, some of these opportunities for Southeast Asian countries to propose work together. And this is a very important and high value crop that is very much of interest in Southeast Asia as well. So perhaps this is something we can explore together in the future. So it's coming to 12, and I know some of our guests will need to leave for prayer soon. So please, will you all join me in virtual applause? Thank you very much, Dr. Endang, and for all your colleagues also for joining us today. It's lovely to meet you all again. And we hope maybe in 2022 we can actually physically visit one another. It will be really nice.
We also can visit UGM.
Yeah, really interested to see the highlands, the cultivation.
So we hope that that's going to be possible next year. Okay, thank you very much, everybody. And we now close the seminar. Thank you.
Thank you, everyone.
Thank you.